Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're taking a look at the chain of responsibility pattern. The chain of responsibility pattern is used when you have a single request that goes to a series of objects in which one of those objects will eventually be able to satisfy that request. But you don't know which object it could be. It could be the first object, the second object, third object, or the 100th object. It's completely up to you. The idea, though, is that you have a sender that sends out a request to a particular object and expects some sort of response back. Now, once that object gets the request, it may send it on to other objects. And those other objects may then decide whether to process that request or not. And then if not, it'll pass it on to another object, and then so on and so forth. And so the idea here is that the sender sends out the request, and then it expects a response from an object, and it doesn't care which object it happens to be. For example, so suppose I had a zoo, and this zoo will request animals from 6 other different zoos. We'll letter them A through F. And I've got to be able to find out which zoo can get me a particular animal on a particular day. And so generally I can just start talking to any one of these zoos. And while 6 zoos is okay, and mostly 6 zoos is what I can show on my screen here, let's assume you had a network of 1,000 zoos. Now, can you imagine being the zoo that sat there and had to call up all 1,000 different zoos out there to be able to say, hey, you got an animal for me today? Can I have this animal? Can I have that animal? So on and so forth. It'd just be monstrous. Well, this is where chain of responsibility can be one of the patterns that you can use to solve this particular problem. And the idea would be is that you would call the first zoo, Zoo A, for example, and say, hey, can you give me an animal? If Zoo A doesn't have it, then it has some sort of mechanism in which it then passes to Zoo B saying, hey, this zoo needs an animal. If Zoo B doesn't have one, it will have some sort of mechanism in it in which it will pass it then to Zoo C, and so on and so forth into F. And the idea here is that once somebody can satisfy the right request, let's say Zoo B, for example, had an animal, it will then satisfy the request and send that animal on back to Zoo. If nobody can satisfy the response, then it comes back null, or some sort of mechanism saying, hey, I've got nothing available for you. But the idea here is that the zoo's response, from the zoo's point of view, it will request the animal from one particular object and then wait for an answer to come back. It couldn't care less whether it just came from that one zoo, Zoo A, or it came from 6 zoos, or it came from 1,000 zoos. It doesn't matter. Somebody is going to fulfill that request, and that request is sent down a chain of zoos that's been predetermined by whatever mechanism you have to predetermine it. And that's called chain of responsibility. So once an object satisfies that particular request, it stops and sends that request back to the sender. Otherwise, it just keeps sending the request down the chain until it is either satisfied by some other object or it is not satisfied at all. And so that's how the chain of responsibility works. You want to see how to do it in JavaScript? Let's get started. The idea here now is that we're going to have a bunch of zoos that are created that have animals, and then we're going to create our zoo that will then ask each of these zoos for a particular, or not a particular animal, but ask for any animal on any particular day, 10 days consecutively. And we're going to use the chain of responsibility to be able to do that. So the first thing we'll need is a zoo object. And this zoo object, actually, let me show you this first one. This is our JSON file that has all of our zoos. This is zoo number 1, zoo number 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11. There's 11 different zoos, each one with about, what's about 10 animals? That's 3, 6, yeah, with 10 animals a piece in it. No big deal there. So we're now going to have a zoo here that is going to be basically a zoo for each one of these individual pieces of the JSON file. That will save all the animals into an animal array, but the most important thing is a transfer animal method. And this is going to be the method that our program is going to call to be able to sit there and say, hey, go call me, or please send me an animal. And the idea here is that it's going to find out whether it has an animal available or not. And it's going to just do a little random number with the length of the animals that are already within the zoo. And if that animal is available, we will extract that animal out and return the value. So basically say, yeah, I've got an animal available. The person who requested this, here's the animal. That will end the chain of responsibility. But the key here is that if we don't have the animals available, so the else if there is a next zoo, we're going to return the next zoo's transfer animal. And what's that next zoo? Well, when we have a class, which is we call Zoo Central, which I'll show you here in a second, constructs this particular class, it's going to pass along to it the object that will be the next zoo in sequence. And this is the key for chain of responsibility, is that each object needs to have some sort of knowledge of what is next in sequence. So our first zoo object is going to know, hey, there's another zoo object, object number 2. Number 2 zoo object is going to say, hey, there's another object, object number 3. Now initially that zoo is going to be null, as you can tell here in the constructor. And then we're going to save it as next zoo. So if there is a next zoo, we're going to return that next zoo transfer animal. If it is null, that means we're at the end of the sequence. And so we just return a empty object here. And so that's really the key to this chain of responsibility, is that we have all these different zoos. The zoo does not have knowledge who requested the information, but it does have knowledge of who is next in sequence, and that's very important. So what we end up building here is that each zoo will know of itself, of its 10 animals, plus it will know what the next zoo is. And if this next zoo happens to be null, that means it's at the end of the chain, and consequently it will return blank. And that's going to be very important. And that's really all there is to this zoo. There's really not a whole lot. Zoo Central is what we're going to have here to build out this particular array of zoos. So the constructor here is very simple. First of all, we read the JSON file. And yes, I know I'm using read file sync, and I should be using just read file and doing an async operation, but hey, it's the way it is. So that will get us all of our zoos. And then we just do a simple little for each loop on them. We grab the name of the animals because that's all we're given there. And then we, first of all, determine if we need to set this new zoo that we've created here in line 15 by just calling new zoo. We need to find out if there is an older zoo or a previous zoo that we need to save this new zoo as a link, because the idea here, again, in new zoo, whoops, that's my zoo, wrong one. In new zoo here is that our next zoo property holds a pointer to the next zoo in sequence. And again, this is chain of responsibility, so it's very important that an object knows who is next in sequence. And that's, whoops, wrong code again. That's basically what this code does, is that if we have an old zoo, and at first the old zoo is null, but if we have an old zoo, we set its next zoo property to our new zoo, and we set the map within our map, which we created on line 11 there. Otherwise, we set the new zoo to our mapping, and we also try to save the first zoo. Why is that important? I'll show you that in just a second. And then we set the old zoo to new zoo. So this gives us the ability to basically say, with our first zoo, the new zoo is 1. Our second zoo, we go back to our first zoo and set the, hey, we got a second zoo here, so that's going to be your next zoo. And on and so forth until we get to our sixth zoo. A, B, C, D, E, F, G. Yeah, get to our 6th zoo. When the 6th zoo comes in, it says, okay, 5th zoo, point to the 6th zoo. The 6th zoo is going to be null for its next zoo, so it will be the end of the sequence. So final thing here is that our first zoo points to the second zoo points to the third zoo, the third zoo points to 4, 4 points to 5, 5 points to 6, 6 points to null. Very important there. Okay, and then all we really have left is a getter function called first zoo, in which we return the first zoo. And why are we doing that? That's because our sender program, which in this case is going to be this creation for our zoo, is going to need to access whoever is first in this sequence. And the first person in the sequence is the very first zoo that we come up to, which will be obviously the very first one. So let's get to my zoo. Very, very simple. I construct a new zoo central. I access the first zoo because that's extremely important. I need to basically send my message of getting my animal to that very first zoo. I'm going to get 10 days worth of animals. All these animals are represented, this animal count here is represented by 10 days. I'm going to call the main zoo transfer animal. That's it. I just call the main zoo transfer animal, so the main zoo is the first zoo. And when I call the transfer animal, say, hey, first zoo, give me your animal. And eventually I'm going to get an animal. It may come from the first zoo, may come from the second zoo, it may come from the third zoo, I don't know. Because if I get to the first zoo and it finds out that I cannot transfer the animal, then it's going to go to the second zoo, and that's what is down here. If the animal is not available, it's going to go to the next zoo. Nice little recursive routine here. So all I care about in this my zoo here is go to the very first zoo and say, give me an animal, transfer an animal over to me. Where it comes from, I couldn't care less. Even if it had 1,000 different zoos to be able to get that animal from, I really couldn't care less. All I want to do is just transfer, give me this first animal. I don't care where it comes from. And that's the beauty of the chain of responsibility. If the first zoo can handle it, great. But if it can't, it just sends the request to the second zoo. And if the second zoo can handle it, great. If it can't, it sends the request to the third zoo, and on and so forth until we get to the end of the chain or somebody is able to fulfill the request. But this is the beauty here. I can have 6 zoos or 6,000 zoos, and I couldn't care less in my program. I just have to make one call and make the same call every single time. So if we were to add zoos in here, if we add a 7th zoo, an 8th zoo, a 9th zoo, a 10,000th zoo, all I got to do is just add it to the chain, and I'm done. My program takes care of it automatically. So then I just go in here and say, I get the transfer animal, I push it to my list, and then I just have a nice, pretty, fancy report. So I purposely set this up to where there is a possibility that we may get a animal that's not transferred. So, and that's basically, what that basically means is that every animal has an availability. And if the availability basically is less than 25% within the zoo. So if I get a animal that's available, I just transfer the animal. But if I don't get an animal that's available when I do my random check, which is right down here, if I don't get an animal that's available, it will go to the next zoo. So it is a possibility I can go all the way through all the zoos and not get a single animal. And you'll see what happens when that occurs. So that's basically it. That's the chain of responsibility. I start off with the main zoo, and the main zoo sends it to any other zoo within the sequence until somebody can fulfill the request. Let's see what that looks like inside Node. I just type in Node my zoo. And there, hey, it happened right the first time. So, day number 0. Ooh, Archie the Aardvark was sent to me by zoo number 2. So that means it went to zoo number 1 and said, I don't have an available animal. I'm going to pass you on to zoo number 2. Zoo number 2 said, yep, I can give you an aardvark. Great. I go in for the next request. The next request, I'll go back to zoo number 1. It couldn't find an animal in zoo number 1. It couldn't find an animal in zoo number 2, so it went to zoo number 3, and that gave me Lucy the ladybug. For the third day, I went again back to zoo number 1, but this time zoo number 1 gave me a dog. Yay! But notice here, I went through all 6 zoos, and nobody could give me an animal. Here, day 4, I got an animal from zoo 2. Day 5, I got it from zoo 6. Day 6, I got it from zoo 5, then zoo 1, then zoo 8, then zoo 7. So that shows you that basically this allowed me to be able to, did I keep saying 6 zoos before? I'm sorry, I didn't say 6 views. We had 11 zoos. Yeah, whatever. So this shows you that all I had to do was request. Let me go back to my code. All I cared about is I requested from the main zoo, which is the very first zoo. And it was responsible for going through each and every single one of these. So if we run it again, first time through I got no animal, but then I got animals for all the rest of the days. 9, 4, 3, 4, 10, 10, 2, 1, and 8. So that is chain of responsibility. I send it off to one object, and then that object has some way of being able to send that request to another object if it cannot fulfill the request. And so on and so forth throughout an entire chain until either somebody fulfills the request or somebody does not. And that's all there is to the chain of responsibility pattern. I hope you enjoyed our video. Hope I didn't bore you to death. Please make sure you click on the like button below and hit the subscribe button to subscribe to this channel. Also, you can go to www.boringjavascript.com to see everything that we do. Thanks again for watching, and we'll see you later.